Okay, so I know that fractions are something that people usually struggle with. Usually people hate fractions. And I'm sorry to tell you that you're going to have to work with fractions in this class several times. And depending on your degree, you may be working with them more. So, not again. Yeah, unfortunately, fractions is not something that you can necessarily get rid of or get away from, depending on your degree. So, um, why do you need to know how to work with fractions? The first thing is just percents. Percents are something that everybody deals with. Everybody deals with tax. You've got discounts and sales. You have, if you're have some sort of interest and you're taking interest out of an account and there's like a penalty. I mean, percents are all over. If you have to take a statistics class, you're going to deal with percents. You're going to be finding averages. All of these things use fractions because a percent is literally a fraction. 25% is 25 over 100. It's just, instead of writing it as a fraction, we're using a different symbol, but it's literally a fraction. So if you're dealing with percents, you are dealing with fractions. And if you're taking averages, you're actually dealing with fractions because you're adding a whole bunch of things up and you're dividing it by how many you have, and that division is actually usually written as a fraction. Proportions. Those are, if you go into any nursing or healthcare and you have to do dosage calculations, you usually do those using proportions. And in fact, any cooking that you do, like if you are making cookies and you need a teaspoon of like baking powder and you're doubling the recipe, or maybe you're not doubling, you're doing some weird thing like you need a third of the recipe, you're trying to cut it down, we usually have to use fractions. To solve those, you use proportions, and proportions are literally a fraction equal to another fraction. So fractions are used there. Any unit conversions that you do, which again are used in dosage calculations, unit conversions are done in physics. In chemistry, unit conversions come up. A lot of people are in college algebra when they have to go on to engineering majors. You're going to be doing unit conversions. All of those use fractions and are set up using fractions. It's often called dimensional analysis, but you're just multiplying a whole bunch of fractions together. If you are in programming, you have to be careful when you do your division, which essentially division is also writing things as a fraction, but you need to understand whether you're going to get an integer, which is basically a whole number, or you're going to get a rational number, generally a fraction or a decimal, because say you're programming in C++, you have to determine your variables, declare ahead of time if it's an integer or something else. And if you declare that only integers are in here and it's not an integer, if you're going to get decimals, that can cause you problems. So you have to understand whether you're going to get fractions out of anything you program so that you can prepare for that. And then again, back to engineering, a lot of formulas in engineering that are involving circuits use fractions. You're going to be dividing by things, or you have to add a whole bunch of fractions up together for parallel circuits. If you have resistors in parallel, you have to, they're all fractions and they're added together. So fractions are more than just something that you have to see in algebra. They actually show up in your life. They show up in other fields. And so it is really important to understand how to work with them because you are going to see it again. So first off, the simplest thing is just simplifying fractions. And it's also called reducing or putting fractions in the lowest form. What this means is that your numerator and denominator, and the numerator is the top of the fraction, the denominator is the bottom, they have no factors in common, or there's no number that you can divide out of the top and the bottom. So when you look at a fraction, you have to ask yourself, can I divide a number out of the top and the bottom? If I can divide the top by 2 and the bottom by 2. If yes, then you need to actually do that division so that you can reduce it. So it's not simplified, you have to reduce it. If not, if there's nothing you can divide out of the top and the bottom, they have nothing in common, then it's simplified and you don't have to do anything else. we always reduce fractions. We never, as our final answer, you never want to leave a fraction in a form that's not simplified or reduced. So that you always have to do this when you're working with fractions. Now, rules for actually some math fractions. So multiplication, when you're multiplying fractions, it goes straight across. So you multiply the tops together, you multiply the bottoms together. When you are doing division, you have to flip the second fraction, so that's what I have circled, and then you multiply together. So you're almost applying diagonals. And this is because of the definition of division. So division is defined as multiplying by the reciprocal. That's just the way mathematicians said this is what division means. And so when you're dividing fractions, we always turn it into a multiplication problem. And the reciprocal is basically just flip-flopping your fraction. So this is just what we've defined. So you always have to flip the fraction after the division symbol, and then you multiply straight across. For addition and subtraction, you have to get a common denominator. You don't need a common denominator for multiplication or division, only for addition and subtraction. And so generally what happens is you multiply one fraction by the denominator, the second, and then the second fraction by the denominator, the first. And when you need to multiply the top and the bottom together, because that way you're multiplying by 1. So you're not actually changing what the fraction is equal to. And so once the denominators match, then the tops get combined, but the denominator stays the same. So those are the major rules for fractions. And so I'm going to go through an example for all of these. So that way you have this, you have a reference, you have something that then you can follow when you have fractions. Especially, this is going to be handy when we go to rational expressions, because those are going to be fractions with variables in it, and the rules are the same. So understanding the rules when you have numbers will help you understand the rules when you have variables. So first, I'll move my keyboard out of the way. I have a problem where we're going to reduce. We have 110 over 176. So there's generally two ways to do a problem like this. The first way is just to keep dividing until you can't divide anymore. And I will do that if they're smaller numbers. I don't usually do it if it's big numbers, but that is one method. So method 1, divide until you can't anymore. So you start with your fraction, and then you try to figure out what number can I divide into both numbers. So I always start with dividing by 2 if possible, because it's easy to see if if I can divide by 2. If the last digit is an even number or 0, like 0, 2, 4, 6, or 8, I can divide it by 2. So since I have a 0 and a 6, both of those, I can divide those by 2. So that's what I'm going to do. When we reduce, we're dividing the top and the bottom by 2. So you don't want to just write the divide by 2 once. You need to write it twice, because we're doing both the top and the bottom. And this also helps you double check yourself. So then on my calculator, I have 110, I divide it by 2, and that gives me 55. And then 176 divided by 2 gives me 88. So now I have to look and say, can this go further? And this one's a little harder, because I have 5 and 8 as my last digit, so I can't divide by 2 because 2 doesn't go into 5. Dividing the 55, I know 5 goes into it, but 5 not go into 88. So this is sort of where you might need to kind of guess and check and kind of think about, okay, just keep trying numbers to see if there's anything in common, which when they're big numbers like this, there usually is something in common. If you just keep trying on your calculator, divide by 3, divide by 4, divide by 5, and try to find something in common, you'll then find you can divide them both by 11. So I'm going to write that down, that I can divide them both by 11. Now 55 divided by 11 is 5, and 88 divided by 11 is 8. And now 5 and 8, I know that there's no number in common. Those are small enough that I can just look at that and I know I can't divide something out of both of those. So now that is the reduced form or the simplified form. This method is good, but it can be hard because like dividing by 11 is not something that maybe you may immediately think about, and you may not know that you can go further. So this is where method 2 comes into play. And this is where we use prime factorization. And so what prime factorization is you're breaking down each number into smaller numbers until you can't anymore. And then you cancel out things that are in common. So I'm going to start with 110. And you make what is called a factor tree. And it's called a tree because it branches out. So you're just splitting it up into numbers that multiply to your number on top. So for 110, I know that's 11 times 10. So I can just see that directly from the number. Now 11 is prime, so I can't split it up, so you circle it. That's the end of that branch. There's no numbers that multiply to 11. But 10, I can split that up because there's two numbers. 2 times 5 will get me to 10. So I split 10 up. And then 2 cannot be split up and 5 can't be split up. So then I circle those. And when you've circled all the bottom parts, if you can't split it up any further, then you're done with that tree. Then you go to your other number, 176, and you do the same thing. For if it's a big number like that, I would just default to dividing by 2. So that's what I did on top. And that gives me 88. And then I can say, well, 88, I know that 8 goes into it. And so you can do 88 divided by 8, and that gives me 11. And 11 can't be broken down. But then 8, well, that's 4 times 2. I have another prime. And then I can split 4 up, and I'm running out of room here. That's 2 times 2. So you kind of just keep breaking it down until you can't any further. Then you take each of these numbers, you multiply them together, and you replace your fraction. So 110, which was on top of the fraction, instead I can write 11 times 2 times 5. And then for 176, I can write 2 times 2 times 2 times 2 times 11. So I need to make sure that I have the correct number of 2's there. 1, 2, 3, 4 2's, and then 11. And then you just cancel things that are in common on the top and the bottom. So like there's an 11 on the top and an 11 on the bottom, so I can cancel those out. There's a 2 on the top and a 2 on the bottom. And when there's nothing else in common, then you multiply it out. So on top, all I'm left with is 5. And then on the bottom, 2 times 2 times 2 gives me 8. So I get the same number that I did on the top. I like the prime factorization method a little better because I feel like there's the thinking I feel like isn't as hard. It's kind of easy to split numbers up as 2 numbers that multiply together, and I don't have to look for something that's in common. Using method 1, when you have large numbers, sometimes it's hard to figure out what's in common that you can divide out. So when you're simplifying a fraction, those are one of the two methods that I would use. I will use method 1 if there's like a really small numbers, and then I'll use method 2 if they're larger. Okay, Cassandra says you can get all the problems with prime factorization. Can you elaborate what you mean by that? I'm not sure what you mean. Oh, like all the numbers, yes. Yeah, prime factorization is nice because you can see exactly what cancels out. Yeah, it breaks it down. And prime factorization is useful when we do factoring. It's useful for finding common denominators, greatest common factor. It's useful in a lot of things we do in algebra. And when we start working with variables and we're reducing fractions, we do a method similar to prime factorization, where you multiply it out, all these little things, and then you cancel things. So, should make a little note that this method, similar to simplifying rational expressions, which you'll see that later. So when you get to that part in a few weeks, you might, if you have this note to yourself, you could say, oh, this is similar to what we did with fractions. Let me go back and review. Because you'll see that the process is, there are a lot of similarities. So this is an example of simplifying. Now I'm just using the term simplify for all of these. Simplify usually means just do the math. So if you have things that you can add, subtract, multiply, divide, any of those things, when it says simplify, it means do that, basically. So here I've got two separate problems. One's a multiplication problem and one is a division problem, and we're going to simplify both of those. So I'm going to kind of split my screen in half, do the multiplication on the left, division on the right. So for a multiplication problem, you would multiply straight across. So we would do like 15 times 7, so you'd have that on your calculator. So that gives us 105. And then 28 times 9, you get 252. And then you would need to reduce or simplify because you have this large number, and you can break it down, you can divide things out of there. What I usually do instead is I try to reduce first. And so I do the same sort of thing with the prime factorization, but I do it in the beginning and then I can cancel things out. So like instead of writing 15, I can write 3 times 5. 28 is 7 times 4. And let's say instead of 4, 4 is 2 times 2. So I can rewrite these in like 7. And then instead of 9, I can write this as 3 times 3. So I can, before I multiply, do the prime factorization. And when you multiply, you can multiply straight across. So that means that as long as I have something on the top and something on the bottom, I can cancel them out immediately. It doesn't matter if they're on different parts of the frame, as long as one is on top and one is on the bottom and you're multiplying. So I can also cancel out those 7s. So if you do your prime factorization first, which is usually easier with small numbers like this, then you can cancel things out and then you multiply just like we did on the last slide. On the top, I'm left with just 5. On the bottom, I have 2 times 2, which is 4, and then times 3, which is 12. And so it's already reduced by doing it this way. So I could do the 105 and 252. I can do the factor tree, but it ends up being more work than doing the factor tree on the smaller parts first. So if you have fractions that you're multiplying together, I recommend trying to cancel things out before you do the multiplication, because it will make it much easier for you. It's less work. So on the right here, now I'm going to take a look at the division problem. We have 55 divided by 9, or over 9, divided by 32 over 18. So when it's division, you have to turn it into multiplication. So this division symbol becomes a multiplication symbol, and then you flip-flop the fraction after it becomes 18 over 32. So we have 55 over 9 times 18 over 32. Now this is another one where if I multiply straight across, 55 times 18, I get 990. 9 times 32, 288. I would have to, again, reduce this. And they're pretty large numbers. So you might have like multiple steps here. So again, instead, I would do the prime factorization, or try to break these numbers up before I multiply. So 55 is 5 times 11, and neither of those numbers can be broken up. 9 is 3 times 3. 18, if it's 2 times 9, and I can split 9 up as 3 times 3. And then 32 is 4 times 8. So I can split 4 as 2 times 2. And normally I'd make a whole tree like I did on the previous slide, but I don't have a lot of room here. So I'm just kind of doing it as I go. But 8 is 4 times 2. And then I can split that 4 up as 2 times 2. So I've got lots of 2's there. So once you've gotten that all broken down, then I can just start canceling things out. I can cancel out a 3. I can do another 3. And I can do a 2. And then once you've canceled that out, then we can multiply across. So I have 5 times 11, which is 55. And then 2 times 2 times 2 times 2 is 16. So you could just put that all on your calculator. And then that is the final answer there. Okay, so the last thing that you do with fractions is addition and subtraction. So again, I have examples of both here. So just like with the multiplication and the division, I'm going to just kind of split this slide in half. And then I'm going to do the addition on the left and then the subtraction on the right. So I've got 3 over 16 plus 1 over 3. In order to add these together, we need to get a common denominator. We usually want the smallest denominator, but it doesn't have to be. If you can't think of the smallest number they have in common, you can use something bigger, and then you just have to reduce further along the road or further down the problem. But the easiest thing to do is just to multiply the first fraction by the denominator of the second, which in this case is 3, and the second fraction by the denominator of the first, which is 16. That's the easiest thing. You don't have to do any thinking if you do it that way. So just like when I was reducing and I wrote the division on the top and the bottom, the multiplication here has to be on the top and the bottom, because we're basically multiplying by 3 over 3 and 16 over 16, which is 1. We're not changing the fraction. So I like to work these going down, so you're going to want to get into the practice to work all math vertically. So 3 times 3 is 9. 16 times 3 is 48. 1 times 16 is 16. 3 times 16 is 48. So when I do something like a common denominator here, I will, multiply. I'm going to work vertically. Sometimes at this point, I'll go to the right to add, because it just seems to be natural. And when you add, you just add the tops, 9 plus 16. So we get 25 over 48. And then you want to try to reduce if possible. So I'm going to just do this in blue. Let's say I wanted to try to reduce 25 over 48. Well, I know 25 is 5 times 5. And then 48, well, I already know it's 3 times 16. And I know that 16 is 4 times 4. And each of those 4s is 2 times 2, so I can convert all of those. So if I try to break down the 25 over 48 into its smallest parts, there's nothing in common between the top and the bottom. So if there's nothing in common, that means it is reduced. So I can't actually simplify it any further, so we get 25 over 48 as our final answer. So if you're not sure, you can always go and try to reduce it, see if there's anything you can take out. Now on the right here, I'm going to do a subtraction problem. We have 12 over 35 minus 1 over 10. Trying to find something in common between 35 and 10 might be harder to do. The smallest thing they have in common is 70. So I could multiply 35 by 2. That gets me 70. And 10 by 7 to get to 70. And that's something that I know just because I've done enough multiplication and division that I know what 35 times 2 is. And I know, oh, that's something that I can do. But let's say that that's not, let's say that's not something that you immediately can think of and you're like, I don't know what number to use. So if you don't know, again, you can just multiply the first fraction by the denominator of the second, and the second one by the denominator of the first. It will work every time, even if it doesn't get you the smallest. So 12 times 10 is 120, and 35 times 10 is 350, minus 1 times 35 is 35, 10 times 35, again, we have 350. And then 120 minus 35 gives me 85. So I have 85 over 350. So now we want to try to reduce, and I know that it's going to reduce because I know that I can divide 5 out of both of these numbers, but we will do the prime factorization method. So I'm going to just write blue here. So I know that 85 can be divided by 5. So I'm going to do 85 divided by 5 on my calculator. That gives me 17. 17 is prime. There's no number that divides into that, so that part is done. And I know that the 35 of 350 is going to be a log one. So 350 I know is 35 times 10. Now 35 I know is 7 times 5, so I'm going to break that up. 5 times 7, 7 times 5, that's the same. And 10 is 2 times 5. Oops. And then all of those can't get broken down anymore. So now I can start canceling things out. So I've got a 5 and a 5 on the top, and that's it. That's all I can cancel. So I'm left with 17 on top, and then I multiply 7 times 2 times 5, and that gives me 70. And that is the final answer. This method that I'm showing to do all this reducing of the fractions, it's very handy if you have an erasable pen or a pencil, because I can just keep changing it in the fraction, erase it as I break it down, and I don't have to go and make a factor tree like this. But if you can do the tree, I mean, there's no rule on how much paper you can or can't use, so you can do the tree if you want to reduce it this way. Usually I don't show the whole tree and I break it down in the fraction as I go, like I showed here, just because it saves space there. But it's up to you what works best for you. You may have to write some directions to yourself on how I came up with these things, just direction from a factor tree. If you're writing your own notes from this, you might have to do the factor tree on your own to double check that these are working out. But this is how it works with fractions. And once you understand the rules and what to do, it's not as bad as it seems, just as long as you know how to break it down. You guys have any questions on the addition or the subtraction? Okay, now I'm going to show you guys a good tool to use to double check your work, and let's say you're taking a quiz and you're running out of time. So you may be familiar with the website desmos.com. So great website. It's great for graphing. That's what most people use it for, but it can do more than just graphing. So if you go to this math tools here, and you're going to want to go to the scientific calculator. And so this gives you a calculator, and this calculator can do fractions. So like that 85 over 350, I can click the fraction button and type 85. I hit the down arrow, go to 350. It automatically gives you the decimal version. We generally never work with the decimal version because it's just not easy to work with. But if you click, you see this little button that says convert to a fraction. It gives you the reduced form. So it reduces to 17 over 70, which matches what we did by hand. And I can hit enter, and then that will save that answer. You can do addition with fractions, subtraction, multiplication. All of this can be done with this button here. And so if I wanted to do the 12 over 35 minus 1 over 10, I could do 12. And if you don't hit this button, the division button does the same thing, because a fraction is division. So then I can hit my right arrow to get outside of this, subtract 1. And on the keyboard, the / button also does the same thing. So the / is I can't draw on here, but it's the one that goes this way. It goes from bottom to top, from left to right. That's the / That is also the division button. So that's a shortcut using the keyboard. So again, I can do the subtraction here. And let's say you didn't convert it to a fraction immediately. You can still hit this button to make it a fraction. And you can hit it again to make it a decimal. The way that the fractions are entered here is the same way that it works in ALEX. the same keyboard shortcuts work in ALEX. So if you like to use the keyboard, you can use the / to get a fraction. You use the arrows to get inside and out of the fractions. It works the same way. But this is a good to double check your work. It's really good on a quiz so that you're not spending your time with the fractions and you can focus on doing the actual algebra. I recommend bookmarking this calculator because it does a lot of things. It does square roots, it does more complicated roots, it does exponents, it does absolute value. You can do variable things with it if you want to. Under this thing, when you get on to if you have to take pre-calc, you'd be using these sort of things. We're going to be doing what's called a natural log and a log, so we'll be using these buttons later in the class. So I recommend bookmarking this thing. It's going to make things easier. You can even put things in with parentheses and double check everything. We've got this button right here. It's really fancy. I mean, I've never tried the Braille. I've never done a Braille keyboard, but it's kind of cool that it even does that. Just really neat. So I would just bookmark this just so you can double check your stuff, maybe take a quiz and have this open in another tab so you can work with your fractions and just make sure that you're not making any errors.